Hello. Okay, today in this vlog we're going to talk about functions. Now, a function is like a rule. It takes one number or one thing, takes it, applies the rules, and changes it, and out comes something else. So first we're going to talk about relationships. Okay, an ordered pair, an x and a y, in a specific order. The x is from the x-axis, possibly, and the y is from the y-axis, and that's fine. Now, the relationship between these two numbers, as you put them together, like 3 and 4, like this. Now, this example, 3, comma 4, have a relationship. Okay? Now, a function. A function does mean a relationship where each input has one specific output. Okay, we'll discuss more of that in the next couple of vlogs, the specifics of proving and how to apply it and what it looks like. Right now we're going to move on to the next topic here. Okay, this is a picture representation of a function. As you put one thing in, you cannot get two different things out. And the second set here, that breaks the rules. The first set of ovals Okay, this function is a function, takes one input and maps it out to second output. 1 becomes 2, 2 becomes 5, 3 becomes 6. And this is a proper function. It doesn't break any of the rules. Now our second example, with the ovals there, as we can see, as I wrote, it's not okay. If you have one input and it comes in the function box and you get a 2 or a 6 or different answers, it doesn't work. That's not a function. It breaks that rule. Okay? Now, we can see we have several relations, f, g, and h. And there are a set of ordered pairs. And we'll look at the f relation first. We have to decide if it's a function or not. And how we even know if it's a function? If we have one x and then two different y's, with that 1x, it doesn't work. And you'll see as we go through examples here. Now, the second relation, -2, -1, we have 0. There's no repeating x's there. Every x has a unique y, so that's good. That's a function. So that's we show that that works as a function. Now look at h, the relation h. We have -4 gets connected with 1. -2 goes to 1. We're okay there. -2 goes to 0. Something wrong with that. Hold on. Nope. That's not a function. -2 goes to 1, and then -2 goes to 0. Either 1 or 0. That can't happen. We need a specific output for an input. We should have expected value. So once you put something in, it comes in, and then the two things come out, like, oh, we'll see what happens. Could be 1, could be 0. It doesn't work that way. That's not how functions work anyways. That's not a function. Now, we have examples A, B, and C. We're going to talk about domain and range with these. And also decide if it's a function or not while we're working on it. Now, domain relates to is the input, what you put in, and the range is what comes out. Now, we'll talk about, now, is this really a function or not? Let's discuss that option. Well, look at the 4, the domain of 4. 4 can be mapped to 2, or 4 can go to 5. It breaks the rule. It's not a function. Okay, now we can see 95 is an A, 89 is defined as a B, 88 is also a B, and that's okay. Because if you were to give me 89, I know it's a B. If you gave me 88, I know it's a B. It's not like it's a B sometimes, or it's a C sometimes, or an A. No, it follows the rule. It's a function. This works. So sometimes feel like, oh, we have all these inputs going to one answer. It's okay, but each input has one specific answer. -5 goes to 2, 0 goes to 2, 5 goes to 2, and that's okay. I can expect this value. It's not sometimes this answer is this answer, or 5 becomes 2 and it becomes 1. We have one input and one output, and it matches. Thanks for paying attention to this vlog. I'll see you next vlog.